Hey, my name is Brent Simmons. I'm going to talk a little bit about the relationship between the electric force and the electric field. There are other students who have been focusing more on electric force and electric field respectively. They go way more in depth than I will be going into today. I'm purely focusing on the relationship between them, but I will go into a little bit of some fundamentals of each thing just so we can get a grip. Hopefully by the end of this, you'll be able to understand some simple concepts of electric force and electric field, but most importantly, understand their relationship with each other. I also hope to introduce you to these equations and see what they come from and how to use them. So let's talk about the force for a little bit. We've got some fundamentals to get a grip on. The first fundamental is that there are two types of charges. There's a positive charge and a negative charge in any system. There is a second fundamental that like charges will repel. So if you have two negative charges next to each other, you will find that they repel each other. Unlike charges will attract, or the opposites attract rule. And number 4, that their force, the magnitude of the force, will decrease with a greater distance. These 4 fundamentals can help us get a grip with what Coulomb's force is trying to tell us, which states that the magnitude of the force is equal to a constant k times a charge 1, charge 2 over the distance, or the r squared. Understanding this equation helps us see the relationship with force and distance, that the greater your distance, or how far away you are, you will feel less of a force, or the strength is not as strong. That being said as well, if you have a small distance between each other, your force magnitude is going to be great. Now, that understanding can help us move on to electric fields. A field is a way that we can conceptualize and map the force, specifically the force that surrounds an object and acts on another without ever touching it physically. This is just like gravitational field. This isn't, you don't actually ending up seeing these fields, but they do a great job at illustrating what is happening. Just like in this gravitational field illustration, it represents how gravity in a gravitational field will be pulling objects toward its center, or the force of gravity pulls things towards it. This gravitational field illustrates how it represents with each other. You may notice these dotted lines along the side. These are called equipotential lines. And along this line, the magnitude or the strength of the field is the same. Now, in the electric world, we get the Coulomb force and its electric field, and they are illustrated in these simple drawings of electric fields. They vary by what charge is at the center. A positive charge will have its field lines of its field directed outward, normally pointing towards an electric field of a negative charge, which has its field lines directed inward. So moving on, we can use Coulomb's law to figure out the magnitude of this force, and we can rewrite that equation a little bit to help us. Normally, we have what are called test charges, represented here by a capital Q, and we have point charges represented by the lowercase q. And if we multiply those two together along with the constant k, and then divide it by r squared, we can find that magnitude. Normally, you throw a test charge into a field in order to find that force. So if we threw a test charge per se into this positive field, then we, at a certain distance, we would be able to figure out the force magnitude and its relationship with the field. We do have an equation that helps us quantify the electric field, as illustrated in this box. We get the electric field is equal to that same constant k times the test charge over distance squared. So we just talked about this rewritten Coulomb's law equation, and now we have this electric field equation, and there is a relationship between the two of them, and there you can use one to find the other, you can find the other to use the other. It's found in the sense that the magnitude of the electric field is equal to that ratio of the Coulomb force and the test charge. So you need the force to be able to understand the field, as illustrated in this equation, that the electric field is equal to the force over the charge. That's the ratio. Here is just a little rundown on how we derived this electric field equation as previously mentioned. Understanding that ratio right here, we can substitute Coulomb's law for F, which would then leave us with the equation found here, and canceling like terms, we'll be left with this electric field equation. So now let's move into an example problem that tells us to find a force. So we're being asked, what force does an electric field of 7.19 times 10 to the 5th Newton per Coulomb exert on a point charge of negative 0.25 microcoulombs? So this question is asking us to figure out how much force, or what is the force felt on a charge in this electric field. This relationship between force and field can help us find the answer. If we rewrite this equation to give us force is equal to the electric field times this point charge, we'll be able to find that force felt. So let's plug in our values here of 7.19 times 10 to the 5th times negative 0.250 times 10 to the negative 6th. And plugging that into our calculator gives us an answer of 0.180 newtons. That means in this field, there's a certain charge in it, and at this unknown distance, we can figure that out later if we really wanted to, but we're told that this charge is negative 0.25 microcoulombs, and we know that the strength of this field is 7.19 times 10 to the 5th. So we can figure out how much force this charge feels in that strong of a field. And this is that answer. It feels 0.18 newtons. So this was just a little run through of the relationship between electric force and electric field. I hope you got a little bit of a more solid understanding of how they can interact with each other and how one is needed to find the other. If you have any questions or any comments, please leave them below and I will gladly respond and collaborate with you. Otherwise, thank you so much and enjoy the rest of your day.